Dear assistants, good evening, everyone. I'm Aghiles, Khris, doctoral student at the University of Ould in Algeria. Today, I have the honor to present you my modest work entitled Correlation between Fabric Orientation with Defect, Formation and Shearing in Taffeta Preforming. I present to you the plan of our work. We began by introduction and experimental methods, result and discussion, and conclusion. Introduction. Objective of this work is study the effect of fabric orientation on the creation of defect during forming of taffeta roving. Analysis of the influence of the orientation of fabric to orientation 22.5 degrees and 45 degrees in the direction of the tool axis. Using a tool with a rectangular shape has an angle of attack of a ridge inclined by an angle of 16 degrees. Investigation of the effect of some process parameters test under 3 different values of blank holder pressure with 2 different configurations of springs. Method, design, and fabrication in our laboratory of a specific device to carry out the experimental test. Finding the analysis of formed defect and the shearing between warp and weft showed the influence of the orientation of the taffeta and the applied pressure. Experimental method. Specific test bench designed and produced in our laboratory. The bench composed by 3 main components: bench, die, and blank holders. Components are interchangeable to use any desired part geometry. The bench is mounted on an electric cylinder to be set in motion. The die is open to allow the behavior of the reinforcement to be observed, measured during shaping. Springs are used to generate necessary forces for the blank holders to apply the pressure on the fabric. The test consists of placing the fabric between the open die and bench, then placing a blank holder on the applying uniform pressure to it through springs placed on the blank holder. In figure 1, move the bench to perform fabric after forming defect are measured in the different phase of the preform. In the picture, we have the fabric forming device designed and produced in our laboratory. So, to perform forming test, we designed a bench specifically for this study. Figure 1. Figure 2, we have the used bench geometry and its dimension. The bench is a modified rectangular parallelepiped with the face inclined at 16 degrees. The bench is a combination of a cube and tetrahedron. Several geometry that promote the appearance of defect given its detail, radii, right angle, and curvature. To facilitate comparison, the 4 main faces of the tool are marked in figure 2. Roving 500 taffeta fabric has density of 500 grams in meters. For each test, a sample of dimension 300 and 300 millimeters is cut, good composite of markers positioned on the yarns intersection part of the warps and weft is used to measure the geometric defect and shear after forming. In the protocol, we have 2 orientation of the fabric, 22.5 degrees and 45 degrees with respect to the main axis of the tool are used. 4 test configurations were considered by varying two parameters, pressure and springs position. Three pressure were applied to the blank holder 447 and 72 and 97 millibar. Two configuration of the springs, four springs in place, 4 springs positioned in the middle of the preform, and 8 springs are around the preform, as shown in figure 4. We have in picture A the configuration with 4 springs in place, and in B we have 18 springs. So in result, preform obtained under different test conditions, the size of the defect are biggest in the configuration with 18 springs. We have here the result of different preform. We have in A 14 with the configuration 14 springs plus 20 with orientation 22,500 and 18 springs with 22 and 5 degrees, and 40 springs with configuration 45 springs and 80 springs. And here we have the slippage. Here we show the slippage that we find on triple pounds of our preform, and sliding is found on the face of the preform. And the result with slippage, the slippage appears at the triple pounds effect of the geometry. Slippage is more important in the case of 22 and 5 orientation of the fabric. This difference becomes even greater for medium and high pressure. This confirms the effect of the fabric position on preform quality. For both fabric orientation, slippage defects are lower in the case of 44 springs plus configuration, location of the springs in the corner for 8 springs increase the defect. The greater the pressure, the greater the intensity of the defect. Sliding appears in the middle of the face of the preform. The sliding is lower for the fabric oriented at 45, especially for medium and high pressure. This confirms the effect of the fabric position on preform quality. The intensity of the sliding seems to vary with the pressure. The tendency is not very clear. The amplitude increases, then decreases. Sliding is mesoscopic defect, so it's sensitive to the variability of local condition. Stress historical. We have here the sliding in the different orientation and different configuration. And the shear is greater in the case of the 4 springs plus configuration for the 2 orientation of fabric and for all the pressure applied. Overall, the shear is lower. In the case of the 45 orientation of the fabric, the shear is weak and does not exceed 12 degrees for all the tests. In conclusion, the relative orientation fabric and bench has a greater effect on preform quality. Mesoscopic defects are more important for orientation of 22,5 degrees. Effect of the springs position. The 4 springs plus configuration of the springs seems to be the optimal. The defect evolves proportionally to the applied pressure. Intensity of the sliding appears to vary with pressure, but remains sensitive to local fabric condition. The shear is weak and does not exceed 12 for all the tests. Thank you for attention.